Even Mars has meteorites. The Mars rovers that we've sent up, there have been 4 up there, three still working. Well, one went up just a couple months ago. This is a cartoon here of a fine painting, I should say, of one of the rovers running into an iron meteorite. And they've found about a dozen or so of them, just accidentally. One of these rovers might run a kilometer in a year and run into 1 or 2 meteorites in that period of time. The surface of Mars appears to be just littered with iron meteorites. Well, once they're there, if they've fallen any time in the last 2 billion years since Mars lost its water and most of its atmosphere, there's been nothing to rust them. They just sit there. So here's the biggest one that was found so far, about 2 meters long. A smaller one right in front of it, that's not quite a meter. And these pictures are pretty much the scale here. And this is the smallest one, I think, right there. It's maybe not quite 20 centimeters to the side. So lots of iron meteorites on Mars. There should be stony meteorites there too. There should be more of them, though we wouldn't expect to see a stony meteorite this big. We might expect to find some the size of these other objects. But they're going to be hard to identify on Mars. Kind of unlikely that the rover with its analytical equipment will identify a stony meteorite, but it can identify an iron meteorite, lunar meteorites. And much the same on Mars. Though Mars is geologically more complex. We often call it the red planet, and it looks kind of reddish if you can look at it in good dark skies. And it's red because of rust. The rock, basalt, is the most common rock that's there, and it contains iron in the chemical compounds that make up the rock, a certain amount of olivine. And when that iron rusts, it turns red, just like rust on Earth. But today you won't get rust forming on Mars because you need water and you need the presence of oxygen. The only oxygen that there is that we can find so far is a little bit in a little bit of water that exists at the poles. There's carbon dioxide ice along with a bit of water ice, and there may be some water in some of the deeper impact craters. It is now thought that there's quite a bit of water in some of those craters, but we'll see when we manage to get there. On Mars, there are some big volcanoes. Now, this thing right there, shown on this topographic map of Mars, is a big gouge, a big valley. Its length is the width of the United States. Its depth is 3 times the depth of the Grand Canyon in Arizona. And as yet, we're not positive as to why and how it formed. This is on the pseudo-topographic map. The topography is exaggerated so that you can see it. Here's 3 big white cap volcanoes. Now, it's not that there's ice on them. The white is just to emphasize the top of the volcano. Can you see them on Mars right here? There's one of them, the southernmost one, then another one. Oops, there's the southernmost one down there. So those 3 of them, plus some smaller ones that you can see in the picture. And the largest volcano in our solar system that we know of is right at the end of that arrow. You can't see it in the picture, but you can see it in the topographic map. It's 22 kilometers high. The largest volcano on Earth has about 1% of the volume of this volcano. The topographic line between yellow and red on this map marks the shoreline of what was once a large ocean on Mars. It shrunk in size, and at one stage, later stage in the history of Mars, the shoreline would have been between the green and the blue. During that stage, Mons Olympus, this largest volcano, would have been a gigantic island. So we can get meteorites from Mars that come from this old ocean. We can get them that come from the old highlands, all this brown and reddish material, and we can get them from the volcanoes as well. So for different parts of Mars provides us with different groups of meteorites, but they're all achondrites. Same as the lunar meteorites, they're all achondrites.